this video, we'll learn about how to use our How to Design Data recipe to design our first data definition. Let's continue with the wait time example from the intro video. The problem statement says, design a data definition to represent the number of minutes that a patient has been waiting to see their doctor. The first step of the recipe is to determine the inherent structure of the information. Here, what we want to represent is the number of minutes that a patient has been waiting. So we want to represent a number. I know that I can use a primitive type, int or float, to represent a number, so I know that I can use an atomic non-distinct data definition. Other examples of atomic non-distinct types are ones that can be represented by images, strings, or booleans. Atomic means a type that cannot be broken down further, and non-distinct means it's not representing a distinct or particular value. In this case, it's not one particular integer, like 7, that we're representing. This data definition can be used to represent any non-negative integer. I know that there are ints and floats. Which one fits best in this situation? I think it's most reasonable to represent whole minutes because I think that's precise enough. So I'll use an int. You may be wondering why I want to create a new type when I can use an int. I will get to that soon. I need to give my new type a name. It must describe what this type represents so that when someone reads the type name in the program, they'll be able to make a good guess about what it represents. In Python, I make a new type name with the data type definition. This code defines wait time as an int. Before I move on to the next step, I need to think about whether all integer values are possible wait times. Since someone couldn't be waiting a negative number of minutes, I can specify that the range of this integer must be 0 or higher. The closed bracket means that the lower bound is included, and the ... open bracket means that the sequence continues or that there is no upper bound. Next is the interpretation statement. Here I'll say the interpretation is the number of minutes a patient has been waiting to see their doctor. Note that I included the units, in this case minutes. This is a key part of the interpretation statement. Without including the units, we might not know if it's seconds, minutes, hours, or days that somebody has been waiting to see their doctor. Now some examples. We tend to use an abbreviation for naming the examples, where we use the first letter from each word in the type name, followed by a number. So I might have my first example as WT for wait time 1, and my second example as WT for wait time 2. Now, since I know these are representing minutes, I might actually go and change that so that the example representing 0 minutes is named WT0, and the example representing 5 minutes is named WT5. Like all names, we want these names to be meaningful. So making small changes like this can make a big difference in how readable our program is. Finally, the template function. We always start with the @typecheck annotation. We don't actually type check the template function since they are not called, but we put it here to remind us to include the annotation in function designs that are based on this template. Then we need the keyword def for define, followed by the template function name. The template function name is always of the same form, fun, for, and then the type name. So in this case, wait time. It takes one argument, which we know is of type wait time, so we name the parameter WT. We cannot know the return type at this point because we are just writing a template function, so we write ... to leave that to be filled in when somebody uses this template in a function design. To see what to write in the template function's body, we can go to the Data-Driven Templates page and find the row that corresponds to the type of data definition that we're writing. We're writing an atomic non-distinct, which is the first row. So I can see that an int is an example of atomic nondistinct, and that then in the body, it should be return ... and then the parameter name, which in our case is WT. Now we've completed our first data definition.